Hello everyone, my name is Mr. Valente. I teach technology education here at Laurel Highlands Middle School, and I've been here for 17 years. We've done a lot of great things over the years, and one thing that we have to make sure of before we start any projects is we need to know how to use a ruler, because if you can't use a ruler, it's very difficult for students to manufacture anything, because we basically produce our projects from nothing. We have stock material, a ruler, a pencil, okay, and then we use machines to solve a bunch of problems, and we put it all together, and usually at the end of the term we have two nice projects that we produce. We produce an operational gumball machine and a very nice Laurel Highlands clock project. We've done different things. We've done LED light bottles and things like that. But like I said, it all comes back to being able to measure. If you can't measure, it's very difficult, okay? So today what I'm going to do is I'm going to give you a lesson on how to use a ruler. We're going to start off with measuring on the 16th scale. We use two scales, okay? We use metric and we use the 16th scale of measuring. The most standard scale is the 16th scale. And that's the scale that they use in construction. And if you go to Lowe's or Home Depot and you order blinds for a window, they're going to ask you the width of it in standard 16th scale. Okay, you're going to have a whole number and then you're going to have a fraction. Okay, so what we're going to talk about now is we're just going to talk about the fraction of the measurement. All right, so before we talk about measuring, we have to understand the basics of it, and the basics of measuring on the 16th scale is understanding fractions. All right, so on your fraction we have a top number, which is called the numerator, and we have a bottom number, which is called the denominator. Okay. If we can relate that to this picture, before I ever shade anything in, there is something that we know from this picture. Okay? Do we know the denominator or do we know the numerator? And we know that the denominator is 4 because there are 4 possible parts. All right? If we shade one, then we know that the shaded part is 1/4. Here's what you really need to know. If we break this up into more parts, our new fraction is going to be 2/8. Which one is larger, 2/8 or 1/4? They're the same. They're equal. They are proportionately equal. We didn't gain any pizza, or we didn't take away any pizza. We just converted it. Okay, we converted on a different scale. We can keep doing this. We can go all the way to 4/16. And then of course we would have to just break this into more parts. And the value of these numbers are in fact the same. Well, that's all it is whenever it comes to measuring on the 16th scale. So let's take what we have here and let's apply it to the inch. This board that I have is a board that looks exactly like 1 inch. This right here is 0, and this on this side is 1. All these ticks that you see in between there are sections that they broke the inch down into. How many parts did they break the inch down into? 16. That's why we say we're measuring on the 16th scale. There are 3 simple steps in identifying any of these measurements on this 1 inch. Okay? And those steps are: 1, count the marks. It's real simple. All you have to do is count. Okay? When we count, do we count right here or do we count here first? We count here first. This is 0. This has no value. This first tick is number 1, and so on. We go 2, 3, 4, wherever it is that we're going to stop on the measurement. Number 2, we're going to place that measurement or that number over 16. Why do you think we place it over 16? We place that number over 16 because our inch is broken down into 16 equal parts. 16 is our denominator. If we were on the 32nd scale, then of course we would use 32 as our denominator. Okay? Step 3 is the part where students sometimes get a little confused. That's when you need to reduce the fraction until your numerator is odd. Okay? Every measurement within 1 inch has an odd numerator, such as 1/16, 1/8, 3/16, 1/4, 5/16, and so on all the way. So whenever you can complete these 3 steps, you can identify any mark within an inch. So let's take a look at it. All right, let's say if we were trying to identify this measurement right here. If we wanted to know what that measurement was, we follow our 3 simple steps. Our first step is to simply count the marks. 1, 2, 3. We place 3 on top, and that is our what? Numerator. Very good. Of course, we're going to use 16 as our denominator. And then our third step in identifying these measurements is to reduce the fraction until the numerator is odd. But in this situation, it looks like we lucked out because our numerator already is odd. Okay? Let's do another one. Let's do one where we have to reduce. Let's do this one. Real simple. 1, 2, 3, 4, 5, 6. Our numerator is 6. Our denominator, 16 every time. And then step 3 states in identifying any measurement we need to reduce. And if we were to reduce 6/16, I understand that you know how to reduce, and you have been taught many times in different classes to go number shopping and find a number that divides into both of those evenly. Well, in this case, let's just do it a little bit more simple. Let's simply break the numbers down in half. So that means we're going to divide them by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. We then look at our numerator and ask ourselves if it's an odd number or an even number. And it is an odd number. So that means that we are done reducing. This measurement right here is 3/8 of an inch. Let's do another one. Let's take a look at this one right here. Let's count. 1, 2, 3, 4. We place 4 over 16. We look at our numerator and we identify that it is an even number. So we have to reduce this fraction until we get it down to an odd number. Again, when you reduce, simply cut the numbers in half. But when you cut the top number, you got to remember to cut the bottom number as well. Some of my students will cut the top number and then they'll just transfer 16 over. When you do that, your fraction is not proportionate anymore and you have a totally different value. So when we reduce this, 4 cut in half is 2. 16 cut in half is 8. But the only problem with my way of reducing is sometimes you get to where you need to be with an odd number on top and sometimes you don't. In this situation, you do not. So that the fact that we have a 2 on top, which is still an even number, means that we have to reduce again. And so what we do is we cut 2 in half now and we end up with 1. We then cut the 8 in half and we end up with a 4. We take a look at our numerator is 1, and that is an odd number. So that means that we have reduced this fraction as far as it needs to go, and this measurement right here on the ruler is 1/4 of an inch. And we'll put a box around our answer to show that. The fraction on this ruler that you need to reduce the most times is the large mark right in the middle. Obviously, we know what that is. Most of you will know what that is. But let's take a look at it. 1, 2, 3, 4, 5, 6, 7, 8. We put 8 down as our numerator. Our denominator is going to be 16. Our numerator is an even number. Therefore, we better start reducing. Half of 8 is 4. Half of 16 is 8. Very good. Still an even number on top. So we better keep cutting. 4 cut in half is 2. 8 cut in half is 4. Very good. And we still got to keep cutting. Okay? Half of 2 is 1 and half of 4 is 2. This measurement is 1/2 of an inch. And that's how we do that. So I think you understand how to identify measurements on a ruler that exist. One good thing about whenever you're reducing the fractions is this one, that one, that one, this one here, and all these other little buggers. 1, 2, 3, 4, 5, 6, 7, 8. Those are 8 that are going to have an odd number. You're going to have 1, 3, 5, 7, 9, 11, 13, and 15. And those are going to be your numerators, and those will have 16 on the bottom. So we would read this one 1/16, 3/16, 5/16, and so on, all the way down. So those are 8 ticks on this ruler that you will not have to reduce. One more thing we need to talk about. What happens when we end up way down here on the end? Well, if we count, we get to the last mark, which is 16. So then we would take 16, place it over 16. You may or may not know that if you have 16 total parts out of a possible 16, then you have one. One what? You have 1 inch. And then what happens after that, if you're measuring something larger than an inch, is you would go and you would have a fraction after that. So let's say it ended up on the other side of this ruler. Your fraction would read 1 and whatever that fraction would be. For example, 1 1/8 of an inch. Okay, so let's take a look at this worksheet. This worksheet is broken down into 16 equal parts. And that on the left side is 0 inches, and on the right side we have 1 inch. All those ticks all the way through this ruler are represented by a different fraction. I'm going to take the time and show you how to identify each one. Letter A corresponds with this spot right here. There are 3 simple steps in identifying all of these measurements. The first step is to count the marks, the second step is to place it over 16, and the third step is to reduce that fraction until your numerator is odd. Letter A is the first tick on this ruler. So our numerator is going to be 1. We then place it over 16. The third step identifies that our numerator is an odd number, so we are done. That is our answer for the letter A. B, 1, 2. We put 2 over 16. Unfortunately, 2 is an even number and it needs to be reduced. I told you that when we reduce our fractions when it comes to measuring, only in my class, we need to simply cut the numbers in half. So 2 cut in half is 1 and 16 cut in half is 8. Our numerator now is a 1, which is an odd number, and then we put a box around it because that is B, and that's our measurement. Letter C, which is right here. It's the third tick in, so obviously we put 3 over 16. This is an odd number. There is no reducing. D, 1, 2, 3, 4. We put 4 over 16. We have to reduce it because 4 is an even number. 4 goes to 2, 16 goes to 8. Oh, the only problem with my way of reducing is we don't get to where we need to be after one time reducing. This one's going to take 2. Half of 2 is 1 and half of 8 is 4. So D is 1/4 of an inch. Next one, E. That's the 5th mark on our inch. We put it over 16. It's an odd number. It does not need reduced. F would be 6 over 16, and we have to reduce it. Half of 6 is 3, half of 16 is 8. 3 is an odd number, we're good to go. We now have 3/8 as our letter F. G, that's 7, 7/16. 7/16 is an odd number. We're done. There's no reducing. Next one, it's going to take some work, but we can handle it. 8/16. Half of 8 is 4. Half of 16 is 8. Half of 4 is 2. Half of 8 is 4. There we go. And just keep breaking this down until what? Our numerator is an odd number. The next one, after this one, which is the 8/16, would be 9/16. We place 9/16. It's already done for us. It's odd. So basically when we do these, we have an odd number, even, odd, even, odd, even. Also, take a look at how small these odd numbers are. Okay. After 9 comes 10. 10/16. It's an even number. It needs to be reduced. 5/8. We're done. K would be 11. 11/16. L, 12/16. Half of 12 is 6. Half of 16 is 8. Half of 6 is 3 and 4. 3/4 of an inch for letter L. The next one after 12 is 13/16. Odd, we're already good. We have 14/16. Half of 14 is 7. Half of 16 is 8. 7/8 of an inch for N. That's 7/8 of the way to 1 inch. That's basically what these fractions mean. Understand that everything we've done so far is less than 1 inch. The next one's 15/16. 15 is an odd number, therefore we're done. The last one is 16 out of 16 parts, and we told you before that 16 out of 16 equals 1. That's right here. We have 1 inch.